In this video, we're going to wrap up Chapter 9, where we've been talking about extinction, and we've spent most of the time so far talking about how extinction is new learning, and it's not unlearning our existing learning. And last time we left off just before we got into the paradoxical rewards effects. Basically, where we're going to start talking about the fact that some of the things that we observe with extinction seem to kind of contradict what we already know about extinction, which is why we're calling these paradoxical reward effects. Now, from what we've understood about learning and acquisition and then the extinction process afterwards, we might expect that with more acquisition training, we should start seeing we should start seeing it to be more hard to extinguish those behaviors. So if a behavior is learned through more acquisition training, it should be harder to extinguish. That's logically what we might anticipate. However, that's not necessarily what we observe. And there are a couple of different effects, 3 in fact, that we're going to talk about that seem to contradict that sort of logical idea that more means harder to extinguish. So we're going to talk about the overtraining extinction effect, the magnitude reinforcement extinction effect, and partial reinforcement extinction effect. Now we're going to go over each of these on their own, give them a little bit more information, and talk about a study that illustrates each of these effects, just so that we have a better understanding of them. But starting off with our overtraining extinction effect, this is the idea that instead of what we would anticipate, where lots of training means that it's harder for us to extinguish that behavior, we find that the behavior ends up persisting the least during extinction, meaning that we see more rapid extinction after extensive training with reinforcement as compared to moderate training. So what we actually see is that with more extensive training, we see less of a persistence of that behavior. That behavior will go through extinction much faster than if we were looking at something that was less trained. Or said another way, we can say with more training, you have more rapid extinction. And like I said, this is odd because we'd probably expect that more training would result in a stronger association that's been learned that should persist for longer. But that's not really the case. And what we think is going on is that with more acquisition trials, with more of those learning or training trials, we create a greater expectancy of that reward, where you come to anticipate your reinforcer more strongly, which would generate even greater frustration when extinction is introduced and lead to faster extinction because of the magnitude of that frustration that comes from higher levels of training. So let's look at an example of a study that actually shows this. So this experiment was done by Ishida and Papini in 1997, say it in the right order. And this is looking at turtles in a runway maze. So usually when we've looked at runway mazes like this, where we have our starting box and then a long hallway that they have to run down, and then we have a goal box at the end, we've usually looked at this in terms of rats. But other species can be used in this kind of a setup, and these individuals use turtles. And so here they had a bunch of turtles who were started in this start container. This wall here, or this door here, would lift out, would open upwards so that they could run down this runway here and reach their food pellets and the goal location. And they measured how long it took to reach that goal, or they were measuring latency. So we can look at what they see here during acquisition, where we're measuring our mean log latency, which is basically how much of a delay do we see before they reach the end of the hallway. So a higher score means that they were slower. And so each of these different symbols indicate a different individual. So our triangle individual is individual number 21. And they started taking quite a long time and eventually sped up and could reach the goal in a fairly short location towards the end. And so we see that learning curve for all 3 of the individuals shown here, where they take a longer time to get to the end of the hallway when they start, but they eventually learn to move faster to get to that goal faster because reaching the goal is reinforced. So their latency drops off, they get there faster over time. So that's their acquisition phase. When they're put into extinction, they would basically run down this hallway but reach the goal and find that there were no pellets. So they weren't being reinforced for that behavior any longer. Now, the thing that we want to pay attention to, because we are specifically looking at our overtraining extinction effect, is how much training each of these individuals had during the acquisition phase. And so you'll notice that each of these individuals started at a different time. So our triangle individual, number 21, started right at the very beginning in session number 1. And they were trained each session afterwards. So they would have had 20 training sessions. Individual number 2 here, or I guess diamonds are 14. So this individual started, it looks like 7 or 8 sessions in, and worked on from there. So they would have had fewer training sessions than the first individual. And our last individual with the circles was started training on session 15, so they would have only had 5 or 6 training sessions. So they each had different levels of training in acquisition before they entered into extinction. And they were all put on extinction at the exact same time, but we see that our first individual, the triangle one, the one who had the most training, shows the steepest curve here during extinction. So if we remember, this is how long it takes them to get to the end of the box. They very quickly started to take longer and longer to reach the end of the hallway because they learned very quickly that they weren't being reinforced. They had that frustration effect where they expected originally to get food at the end, and when it didn't happen, they very quickly learned not to hurry because there wasn't food anymore. Whereas our circle individual, who was trained the least, ended up persisting and going very, very quickly for quite a long time, and they were the slowest to start showing extinction effects. So the turtles that were trained for longer, who had more days of training, showed more rapid extinction, and those that had less training showed less rapid extinction. For our second of our paradoxical reward effects, we're going to look at the magnitude reinforcement extinction effect. And so what we end up observing here is that we will see more rapid extinction if an individual is trained with larger rather than smaller magnitude reinforcers. So having a larger reinforcer when you're being trained leads to more rapid extinction. And this is paradoxical because we might expect that if you were receiving a large reward, you might be more motivated to persist and maintain your behavior even when extinction starts. But in fact, we see that they are the quickest to go through extinction as soon as it starts. And again, the reason for this is because having a larger reward would generate greater expectancy of that reward, and then might lead to larger frustration when you don't get that reinforcer. So that would lead to more rapid extinction because you're more frustrated about not getting what you expected. So you're going to learn something new quite a bit faster. And so again, we have another experiment that looked at exactly this time in rats, running along that same type of hallway where we have our start box, our runway here, and then our goal at the end. And they looked at rats who were reinforced with either large amounts of food or small amounts of food during their acquisition. And then we look at how quickly they go through extinction. And so our graph here, we have our response time, which is an inverse response time, where a smaller number means that they took longer. With all of these graphs, it's frustrating that they don't all use the same measurement. They all have sort of their own way of interpreting stuff. But what's going on here is this is extinction, and because it's the inverse of response time, when it gets lower, it means that they're taking longer to get to the end of the hallway. So what we're seeing here is our individuals who were reinforced with a large amount of food during acquisition show a much steeper drop-off here, meaning that they started taking longer a lot faster, meaning that they're showing a lot more extinction very, very quickly. And they get down to taking a very long time to run down that hallway within the first 2 blocks of trials. Whereas the group that was reinforced with a smaller reward during their acquisition phase, they took a lot longer to get down to very low levels of responding. So they're still going fairly quickly down this hallway for the first couple of blocks of trials here. They will eventually get down to that extinction level, but it takes them longer. So again, we're seeing more rapid extinction for individuals that had been trained with a larger reinforcer than those with a smaller reinforcer. For our third and final of our paradoxical reinforcement effects that we're going to discuss, we're going to talk about the partial reinforcement extinction effect, or PREE. And this effect is looking at the fact that the schedule of reinforcement that was in effect prior to extinction is important. So whether the individual was on a continuous reinforcement schedule or an intermittent reinforcement schedule during acquisition, that can affect how quickly they go through extinction. Now, there's been tons of research looking at this, and even within our partial reinforcement schedules, there's a lot of variability on whether it was a interval or ratio, or whether it was fixed or variable. There's lots of research into that, but what we're going to care about is sort of the bigger picture, the stuff that's a little bit more reliable and readily agreed upon, and that's the difference between a continuous reinforcement schedule, or CRF, and a partial reinforcement schedule, a PRE. And I sometimes call it an intermittent reinforcement schedule, same difference, just that it's not being reinforced every single time. And so, excuse me. And so, again, what we might expect would be that if you were on a continuous reinforcement schedule, that you would have a stronger acquisition and that you would persist for longer. But in fact, what we find is that individuals on a continuous reinforcement schedule end up showing much faster extinction. And the idea here is that with a continuous with our continuous reinforcement schedule, what we see is that they have larger levels of frustration when they are then not reinforced, and so they show more rapid extinction. With partial reinforcement schedules, they have less frustration and show more resistance to extinction. And this is something that we would see in, say, gambling. So if you were gambling and you received money every single time you pulled the slot machine when you were learning, and then all of a sudden when the learning session ended and you stopped receiving money, you'd probably walk away fairly quickly. But instead, because we have a partial reinforcement schedule, where sometimes you get money back and sometimes you don't, you're a lot more likely to persist. That uncertainty, those lower levels of frustration because you've come to expect non-reinforcement, ends up allowing you to persist in that behavior even if extinction came into place. All right, so that brings us to the end of the chapter. So I'm going to just very briefly remind you of the topics that we've covered in this chapter. So we talked about a bunch of forms of recovery, ways that we can see behaviors come back even after extinction. So we can see spontaneous recovery, which occurs after the passage of time. We can see renewal, where the behavior starts occurring when we change our context. We might see reinstatement. Whenever we have re-exposure to our unconditioned stimulus, we can see that behavior coming back. Or we might see resurgence, when the extinction of another response can cause an increase in the first response that had previously been extinguished. So the first three only necessarily apply to one behavior at a time. Resurgence brings in the existence of other behaviors within our environment. We also talked about ways that we can enhance extinction, where increasing the number of trials and spacing those trials out can make us more resistant to extinction. You can also enhance extinction if you repeat those extinction trials and complete them in multiple different contexts. We also find that having compound stimuli can also help enhance extinction because compound stimuli are more resistant to extinction than the individual elements that might make up those compound stimuli. And then for today, we talked about our paradoxical reward effects, where we talked about our overtraining extinction effect, our magnitude reinforcement extinction effect, and partial reinforcement extinction effect. So we covered quite a few topics in this chapter, but that's your reminder of all of them.